But we can do much better now in terms of energy. And I have some good news to share with you. We have reached grid parity in most part of the world. So, in all of these big economies, producing electricity through solar panels or other solar technologies is actually cheaper than producing energy by any other means. So this is actually very good news, and the source is not very suspicious. It's a Dutch bank, so not a very scientific organization. So if they say this, I actually kind of believe it. And this is 2015, as the technologies keep increasing, or improving, now we have better yields. This is another of these plots that should be, in my opinion, in every chemistry textbook. It looks very complicated. It's extremely simple. What this plot is showing you is the different technologies, solar cell technologies, to produce electricity from solar light versus time, and see the kind of improvement we have obtained in the last 40, 50 years. And this increase is not linear. There are steps. Those steps are breakthroughs that usually happen in universities, like the ones that I'm highlighting here, or maybe national labs, fundamental research. And now that we are advocating for International Year of Basic Science, this kind of plot is very useful. Main breakthroughs happen in universities or national labs. And now when you get efficiencies which are high enough, now companies like these spin-offs are taking those breakthroughs into the market. I do believe that those entrepreneurs that will take scientific discoveries to the market are going to be the most important agents of transformation for this century. Nobody knows which energy technology is going to win. Most likely it's going to be a mix, and it's going to be depending on your location. What kind of resources do you have? But we know that chemistry will play a major role in producing energy more efficiently. We will need the periodic table. We will need the elements in the periodic table to produce this energy. And as we were hearing in this morning lecture, we should be using elements which are abundant. We cannot use the whole periodic table. Of course, we cannot use the super heavy elements. We cannot use the scarce elements. We need to use earth-abundant elements. And there are very few of them. But I have, again, good news for you. The periodic table used to be a two-dimensional chart. Nanotechnology is adding a third dimension to the periodic table. What do I mean by that? When Mendeleev was organizing the elements, he was thinking of individual set of properties for each element. When he was thinking of carbon, he had coal in mind, maybe graphite. And he was organizing the elements based on the properties on one particular allotrope of carbon. But now we have many allotropes. So indeed, nanotechnology is adding a 3 dimensions because it's not only the atomic number who is defining the properties of the element, but also what kind of a structure you are introducing in that element. And I have, again, good news for you. Just last month, there was the report of a new allotrope of carbon, a beautiful structure. That structure, the cyclo 18 carbon, doesn't have any hydrogen atoms. It's a pure carbon molecular allotrope of carbon. The other ones, even graphite or diamond, will have some hydrogens in the surface of the crystal. This one is a purely carbon molecule, which is a new carbon allotrope, which is actually a molecule. So every day, we are increasing the different tools that we have from the periodic table, going from the two-dimensional table that we all study to this new three-dimensional table that nanotechnology is introducing. Again, this morning there was a fantastic presentation on batteries. I'm not going to say too much, first of all, because it's not my field of expertise, but I really want to introduce a few examples just to show how by using nanotechnology, to use nanostructure electrodes like this templated nickel electrode for the production of batteries, you can have extremely high charge and discharge batteries like this one that charge and discharge in just 1 minute. But this one is based on nickel. What if now you use a more abundant elements to produce your anodes, like this battery that uses aluminum, and it has a very high power and energy density, where it's extremely lasting. As you can see, it can last for many cycles, over 3,000 cycles, using just aluminum and graphite. So there is a lot of hopes for using alternatives, not just of lithium, but also when we are thinking of other elements like the one I'm mentioning here. But if there is one process which is very inspiring, it's definitely photosynthesis, converting CO2 into fuels. Plants convert CO2 into carbohydrates. Those are our fuels. But CO2 these days can also be transformed into other kinds of fuels, fuels that can actually replace fossil fuels. And again, one of the most inspiring pieces of research of the last few years has been the artificial leaf, which is quite amazing. You can see in this little video here how this system that contains a photocatalyst can split water into hydrogen and oxygen with no wires, just by exposing the catalyst, the photocatalyst, to solar light. It's just unbelievable. Another advance in the field has been the production of black titania and black semiconductors that can absorb the spectrum of visible light in a more efficient way.